Okay,
slides.
I can show the agenda again. So this is an agenda, like as I explained, like I give a overview and like introduction, and I do a demo, and Mark do a transformation introduction and demo, and Mogenous team will show demo of how it is done in Mogenous. Okay, this is where like I ended, right? Like before I realized I couldn't share my screen. So just to be clear, like what is CD in a box? Huh? Like this is like something like yeah, we put into a collection of softwares like which does like creation, storing, and like publishing of like common data element according to the CDE semantic model that we were developing for past 1.5 years or so. So what are like basic requirements to run a CD in a box? I try to divide them into two parts. As a user, you need to have like a basic knowledge about like Docker and some basic knowledge about like a GitHub and awareness of a CD semantic model. And yeah, ability to complain when things are not working, because this is something like we quickly put together. So we expect it to break, and or like maybe like there are some features like it could be like more friendlier. So use it, and if you run into some problems, please raise an issue in GitHub. And in terms of system, like yeah, if your laptop or like if your server, yeah, you have access to laptop or server, make sure like you have like a Docker engine installed in those machines, and you need to have like a Docker Compose application to run it. And we tested it in like Linux, and also like Mogenous team tested in Mac. It worked. And if you have like a Windows, good luck. I expect it to work, but if you have some problem, like please let us know. We can try to fix it or like try to debug it for you. Okay, let me give like a short overview of CD in a box components. So this is an abstract design of like the entire like a set of applications that we use CD in a box. So we have this layer called like Bootstrap services. So basically like what happened here is like we will like set up, or like yeah, when you like run this Docker setup, you get to have like yeah, some kind of like a storage layer and like some layer to like run like semantic queries. And we have like a metadata or like a data service layer. There like yeah, you have like access to like a metadata publishing softwares like a fair data point. And if you use like Mogenous instance, then you also get like a EDC system, which also like yeah, give you ability to like populate or like capture data for your registry. And we have like the third layer is a data transformation layer. So here like the actual data transformation happens, like here like we take data from your EDC system, or like you provide us like a location where like your data is available. Then like we translate that data into RDF and publish into like yeah, data storage layer. So we have like two variety of CD in a box to show today. The first variety is like one without like a EDC system in place. For bootstrapping, yeah, we use like a GraphDB and some scripts. I explain it later. And this instance has only metadata publishing layer. It doesn't have a data publishing layer, so it has only fair data point, and it uses like some of like Mark's magic to convert like data and store it in like a bootstrap layer. And we have like a second variety from Mogenous team. So they use like a bootstrap layer, and they modify like the data or metadata service layer. Here like we use Mogenous as a EDC system, plus Mogenous also like as like a FTP behavior in it. So we replace like fair data point software, and we simply like use like Mogenous system here. And Mogenous system like it communicate with like data transformation layer and little like a data transformation layer to do transformation and store it in a triple store. So I will explain about like Bootstrap and metadata layer and show a demo and hand over to rest of members. So for the Bootstrap layer, so as I said, like this is basically like a triple store. So because since our semantic model is like RDF based, we need a triple store to store this content. So we use triple stores to store like a CDE RDF plus also like metadata RDF document that we generate using like fair data point software. Yeah. We also like secured like GraphDB access, because that's also one reason like why we chose like GraphDB. So it's a triple store, but you also like sort of like a close off access to triple store to external users, for example. So anyone like who's coming to your triple store, they need to have like a username and password to access content of your triple store. And another nice feature about like a GraphDB is like it also let you to create like multiple virtual endpoints in within GraphDB, meaning like you can also put like a slices of data in different endpoints and give access to like one of those endpoints. For example, like if you want to give like access to only like counting queries, then you can just put like relevant information which can facilitate counting in one endpoint of a GraphDB, then share it with others. So if you want to learn more about like GraphDB, you can just go to their website, and this is one of the few commercial like a triple store which still offers like a free edition for community to play with it. Within a Bootstrap, like I also added like this service called like GraphDB Manager service. So what it does, it like basically like it creates like two repositories in GraphDB, which can also be used as like a separate endpoints, FTP and CDE repositories. And these two repositories are used by other services like Fair Data Point and like Marks Transformation services. And also like the small manager service, what it also does is like it makes sure like GraphDB is like closed off, like by default, like GraphDB is open, but you have to write some small like configuration to close it off. So this service also do that for you. And for the metadata service, like we are using like a Fair Data Point. So we use like a reference implementation of Fair Data Point that is like developed in Netherlands. So we use this software because it's like a free and open source software, and we don't have any license issues if you want to use it. And the newer version of Fair Data Point also has an option like which let you to add different types of metadata model other than like what Fair Data Point specification says, right? Like for example, like we have like metadata model for EJP RD, and with this Fair Data Point software, you can also add like that metadata model, and you can populate a Fair Data Point with that metadata model. And yeah, like as I said before, GraphDB Fair Data Point content is actually stored in a GraphDB, which is set up in a Bootstrap strip. And in the metadata service, like we're also providing like a Fair Data Point with this user interface. So that user interface like serves content for both human and machine agents who visit Fair Data Point. So for human, the user, we have a simple user interface where like users can browse through different layers of metadata. And we also have like a rudimentary search functionality in this user interface. You can also just search for content that is described in Fair Data Point, a simple search based on like text. And for machine, like a Fair Data Point, like UI also supports like a linked data platform get call. So as a machine, you can also drill through different layers of metadata, starting from catalogs to all the way up to like distributions. So with that, like I show demo of like both Bootstrap and metadata services. So as I said, our version of CDE in a box is like available in this GitHub repository. So first thing what you have to do is like you have to clone this entire like a GitHub repository, which I already done. So this is how my GitHub repository looks like. As I said, like we have like a three, we classified like services in like a 3 blocks, right? So we have like a directories like with those names here. So Bootstrap, CD ready to go, which is transformation service, and metadata service. So the first thing what you have to do is like set up like a GraphDB and start like Bootstrap service, because this is used by other services within CDE in a box solution. Due to like a license issue, we are not allowed to distribute like a GraphDB source code. So what you have to do is like you simply visit this like page of GraphDB, and you just register yourself, and they send you like link to download like a GraphDB source code. So you download it, and it is a zip file. Once you download it, like in my case, I already downloaded it. you have to place like that source code in this particular directory of within like a Bootstrap repository. So the only configuration then you have to do is like make sure like what is the version number of your downloaded like source code. In my case, it's like 9.7, and I also download like a free version of GraphDB. Then you have to just change those configurations in like the Docker Compose file. So the version number of GraphDB and which edition. So all those things, what I'm saying is actually also like documented here. And the things that I say, if they are not documented here, like please do raise it. We will just try to add it. So in my case, like I did all those steps. Yeah, just not to have any surprises, you know. So I'm ready to like run this particular service and yeah, get it up running. So in order to run the service, like you simply do like a Docker Compose up. And in Docker Compose, like we have something called like daemon mode. If you do this, like then everything runs in the background. You don't get to see any logs. But for this demonstration, I ran it without daemon mode. So if there is some problem, we can also see it. So it started creating like some folders for like making like a content persistent. Now the GraphDB is like starting up. It takes some time. So now GraphDB is done. Once GraphDB comes online, like the repository manager service, what it does is like the creation of repositories. For example, like it created like FTP repository and CDE repository, and it also like secured like a GraphDB repository itself. So to prove that, I open like the public, private mode in Google, and so once you run your CD in a box solution setup in like a local host or like local machine like my computer to access GraphDB, this is the URL you should visit. So once I enter it, GraphDB will ask me to enter username and password, or else like I can't access like this particular GraphDB at all. So in my case, so I already know the username and password, which is admin/root. You enter it, and you get into the GraphDB, and you can also see like it created like two repositories for you. I show you like a fair data point repository. So by default, like it adds some statements, which are like statements like GraphDB use for like reasoning. So now like we are good to go. Now, as it is explained here, you can go to like next step. So if you want to set up like a metadata service or like transformation service, you have to make sure like GraphDB is running, or else like you can't successfully like execute those services. So in my case, I did those checks, and I also made sure like I have like repositories like FTP or like a CDE available in GraphDB. Now I can simply like go and like run like a fair data point service now, or like metadata service now. For that, I get into like a metadata service, metadata directory, and again like do like a Docker Compose up. And again, I'm not running it in a daemon mode in case like if I get error to check it. So when you hit, what it do is like I just set up like a fair data point API for you, and it also like set up like a fair data point like a user interface for you. So it takes some time because fair data point is like a big application, and it takes like a few seconds to set it up. Okay, now the application is up running. By default, like it runs here. So again, like I go to the private mode just to make sure like I'm not faking anything. So right now, like I didn't like initiate my, I didn't like open my fair data point, right? Like, so the total statement here is like 102. So when I open my fair data point, then I get like a default content like populated in the fair data point. Then if you go back here and when you refresh, then you see like the number of statements changing. So whatever like a content was added here, like it's actually stored in a GraphDB now. But you need like a secure access to query through the data, but fair data point, it acts like a username and password, so it knows how to query it. So by default, like the fair data point software comes as empty, and we also configure it that way for CD in a box. It's just like we give you option to add the content yourself. So if you want to add content, you simply like log into the fair data point. The default username and password also like explained in the README file. You just log in, then you can just add content. I will show like how to add like a catalog, for example. You just simply click like add button there and give up some title and like yeah, some publisher name. So The bold text here indicate like those are like mandatory property that you would need to add to successfully publish this layer of metadata. So for demonstration, I'm going to add only those layers. No, why not? Just add everything. Sorry, I also like over myself. So whatever you add in the fair data point form will be generated. So we generate like RDF out of those form entry, and this RDF is stored into like a triple store basically. So when you click save button, so by default, like fair data point keeps everything as a draft mode, because at this point, fair data point really don't know like if you really want to continue further editing this document or not. So if you're happy with your like edits, and if you want like this document to viewable for public, then you can simply say like publish. Then fair data point will publish that document. Now, when you go back to the GraphDB and refresh it, then you see like the statement changes because like we added new content. So with that, I'll stop my demonstration. I will hand over to Mark, and he will continue with the transformation demonstration.
So I'm going to show you in a minute a demonstration of transformation services, but I want to first walk you through in a little bit of detail what it is you're going to see and what your responsibility will be as data providers versus the responsibility that we're going to take on to support you. So what you will see is a document like this, which is the documentation for a CSV file. It has columns PID, which are patient unique identifiers, unique ID, which is some globally unique identifier. I use a millisecond timestamp, but whatever you want, as long as it's universally unique. A sex URI, so this is for the personal information CDE. So the personal information CDE has gender and sex and birth date. So the sex URI, and we limit what the possible responses are, which are female sex from the NCIT, male, undetermined, and unknown, all of these terms from the NCIT. And then the next column is sex label, which is human readable, but of course you'd want it to match the sex URI. And then finally an ISO 8601 compliant date string for the birth date. So that's what you see is the instructions for a CSV file, and you must then generate a compliant CSV file. And you put that into a folder, and that's all, right? What you don't see is everything that we're going to do for you. So what we've done, as Rajaram said, we've been working for a little more than a year on modeling the CDEs. We're getting close to the end, I think, but we're still tweaking the models a little bit. So we're using as our grounding ontology the semantic science integrated ontology from Michel de Montier, who's at UMaastricht, and the upper level of SCIO ontology has these entity relationships that we're using. So there's an identifier that denotes a particular role and an entity that fulfills that role. So an entity could be a human or a model organism or a medical device or any kind of entity. And the role could be patient role, physician role, donor role. And then the identifier is what denotes the role. So an identifier is associated with an entity, but it's only via the role. And the role is realized in some process. So if you imagine that a driver's license ID number denotes your role as a driver, and that is realized in the process of driving. And you are the person who drives. Okay, so identifier denotes role. Role is realized in some process, and we have different types of processes. And the process will have some kind of output, which is an observation. And that output generally will refer to some quality of the entity. So for example, taking a blood pressure as a process, it has an output of 120/80, which refers to the quality of blood pressure, or systolic blood pressure, or diastolic blood pressure, for example. And those are attributes of humans. So that's the upper level ontology. So if you think about the CDE of personal information having birth date and sex, what does that look like when you put it into this model? Right, so here's the CDE number 2. And it looks like this, and I'll just walk you through to show you that this is in fact exactly the same as the model before. So we have a person who has a quality, some quality, which is of type birth date, and that person has a role, some role, and their role is a patient, and that role is realized in some process, and that process has an output, which is some output, and the quality is the basis for that output. So the birth date quality is the basis for that output, and it has a value of the birth date. And we do the same, of course, for gender, but we put them into the same model because in that CDE you have both qualities, the birth date and the gender, in the same model. In this picture, we're using the SNOMED code. We've decided not to use SNOMED because of licensing issues, so now we're using the NCIT equivalents of those codes. So this image is a little bit out of date. So how are we going to fill those models, or how are you going to fill those models? So the current approach is that we're going to create this sort of lingua franca for CSV. So because it's an easily generated format from spreadsheets and databases, both of them are able to output CSV. We will create that template for you. So I showed you the column headers. It doesn't matter what order those headers are in, so that's not important, as long as the headers are called what we ask you to call them. So it's the name of the header, not the order that's important. So we have standardized the column headers, and we tell you in the documentation what data you need to provide in each column. And we provide one of those templates for every one of the CDEs. We will then pass your CSV through a transformation pipeline using an emergent set of technologies called YARML and RML that I'm going to show you in a moment. And you can play with this yourself using a tool that I think I showed many of you a week ago or so. So just to quickly talk about these technologies, so RML is an extension of R2RML, which was relational to RML. It allows more heterogeneous data sources and formats to be described. For the moment, we are only going to use CSV, but I would imagine that by this time next year, we will have expanded to other formats. It's just CSV is the easiest one to deal with. I've been using it actually since very early iterations, about 2 or 3 years ago, but it's now very mature. It's coming from Anastasia Dimou at Ghent. But you can see that this is still an unofficial draft fairly recently, less than a year ago. And this is what it looks like so we're looking at RML. So here is a input CSV that has column headers, ID, stop, latitude, longitude. This is what an RML mapping file looks like. You say the source is this CSV file over here, and then you start to create triples. So subject is using a template URL, which is airportexample.com/ and then this ID refers to the ID column header. And it is of type transit stop. And then the predicate is transit route, and the object is stop, which refers to this column header, and its data type is an integer. And similarly with the latitude and the longitude are references to these column headers. And when you apply this mapping onto this input, you get the following triples: example.com/6523, which was the first row, type transit stop, 6523, transit route 25, 6523, latitude 50.9, and so on. So this turns out to be difficult to debug, difficult to maintain. So we're using yet another technology, which is a technology called YARML, which uses declarative rules to create RML. So it's a lot easier, and we can add some metadata, and we can add various other things. And again, this is hot off the press. It's a very modern, contemporary technology, still being developed. So what I'll do now is I'll stop the slide deck, and I'm going to switch. It'll just take me a moment. Okay, now I need to share a different screen, which is my Linux screen. Okay. Okay, so this is the CDE in a box now from the perspective of data rather than from the perspective of metadata. So the CDE in a box, sorry, let's go up one folder. When you run, excuse me, when you run the Docker Compose, so Rajram was showing you the Bootstrap Docker Compose. I have a second one that will connect to the Bootstrap network, so you'll be using the same GraphDB. So I have a Docker Compose here, and when you run that, you will have a folder called data and a folder called config. In your data folder is where you will put your CSV files. So I have just one CSV file. It has some sample data. So PID, again, exactly the same template, PID, unique ID, sex URI, sex label, and birth date. In this case, it's 3 males. And then in the triples folder, there's nothing at the beginning of this demo. Right? In the config folder, we will provide you with a library of YAML templates. The YAML template is named according to the CSV file. So personal.csv corresponds to personal_YAML_template. So a disease history CSV will be disease history_YAML_template and disease history.csv. So we're coordinating everything based on these sort of tags, the file names, the data type names. And so what I'm going to do now is show you that I'm going to bring up my Docker Compose. While it's coming up, I will show you. So this will, at the moment, because we're on different machines, I am not connecting to Rajaram's network, but in principle, this will connect to Rajaram's Bootstrap GraphDB. But I'm on my own laptop right now, so I'm connecting to my local GraphDB. I'm passing in the username password for GraphDB, so it is secure. I'm doing that using environment variables. So here's the CDE in a box daemon. And then step number 1 of the transformation is another Docker image. Step number 2 of the transformation is another Docker image. And we're keeping all of the data on a Docker volume just to make it less likely that you'll accidentally delete it. Okay, so GraphDB has started up. I will now go to GraphDB, reload it. Oh, that does not look promising, does it? Oh, it hadn't started. There we go. Okay, so I have a query to retrieve the patient identifier and the label of their sex. So again, the path is identifier has a value, identifier denotes a role, a person is a person has that role, a person has a particular attribute. That attribute I'm going to say must be male, so I'm fixing the NCIT ontology term for maleness, and then I'm going to grab the label of that attribute, which is the human readable label. I could go the other way and say that role is realized in a process, that process has an output, that output has a value, and that output refers to an attribute. So I can go through either path, so either identifier, role, process, output, attribute, or I can go identifier, role, person, attribute. So there's two paths to get to the same piece of data because there's a little circle in that overall model. If I run that, we get nothing because there's nothing in my triple store yet. So what I'm going to do now, if we look back, there's a daemon that is listening on port 4567. If I call a get to port 4567, I can do that using curl, I can do that using wget, I can do that in my browser. You'll see that that now triggers the beginning of the transformation. So it's ready to transform personal, it's created the INI file, it's created the RML file. You'll see here, there's the RML file, which has been automatically created. It's now creating the fair data, and it'll finish in a moment. So there it's giving a little bit of output, and now it's putting those triples into the GraphDB. So while it's doing that, that takes a little bit of time. You'll see that my data folder now contains the RML. It contains a polished YAML file, which now refers to your CSV. It contains an INI file for executing, and in the triples folder, it now contains the triples. So there's the triples that were generated by the transformation pipeline. And if it's now finished, it should be. Sometimes GraphDB gives me an indication that it's done, sometimes it doesn't. So let's just go and query. And again, most likely you won't be executing this yourself. You'll probably put it on a cron. So if you wait for a few minutes, the process will finish. And if we now run the query, there's our 3 patients. So the upshot is, what you will do is you will bootstrap using Rajaram's bootstrapping image. You will then set up a data folder, a config folder, and a data triples folder. You will put your CSV into the data folder, and you will call get on the localhost 4567 port, and that will trigger the rest of the pipeline to execute automatically. And you can put that on a cron so that it runs nightly and takes snapshots. You will, well, whenever you've generated your CSV, you can trigger the pipeline. Now, so I've just finished doing this for Noel in the Duchesne, and so right now I'm logged into the Duchesne server, and you'll see that what I've done for them is I've created a fairly extensive library of these templates. And then we have an automated extraction pipeline to use their API to get the data into the CSV, and then we apply the appropriate template to the appropriate CSV file. We will be doing exactly the same thing for you. If we look at the CDE model implementations, we have a folder called Transform Templates. And that folder will be automatically loaded for you into your config folder. So you will always get the latest version of the config file, of the template files, automatically loaded every time you do a pull of our Docker image. And again, you can put that onto a cron. I've actually created a little script for Noel that does all of the pulls automatically, and I've just put that script on a cron. So I pull all of the new templates in on a nightly basis, and then I apply them. And so we will give you this template, this library of templates, which will be refreshed whenever you pull. So you'll always have the latest models.